Okay. So hi, my name is Brad Millington, and I work on the Web Tools team. We own the tooling for ASP.NET in Visual Studio. And before that, I was actually on the ASP.NET platform team as well. So kind of got a little bit of experience in both the platform and the tools. And today I'm going to be talking about a tool that we've released as a web download to kind of just get it out into the community and kind of demonstrate what can be done to bind web forms to DLinq Schema. And then I'll be talking a little bit more about what our future plans are for that tool as well. So just kind of a high-level overview what the agenda will be. So I'm going to talk a little bit about what BLinq is and give a quick demo, and then we'll kind of drill in and talk a little bit about how DLinq or how the BLinq prototype works, and specifically as I kind of go through the code gen for the BLinq prototype, I'll talk a little bit about how the object data source in ASP.NET works and how that integrates well with the code gen from BLinq. And we'll talk about a few specific scenarios, how data is selected, how we do sorting and paging, and how we do updates, inserts, and deletes using DLinq against our object data source. Then I'll talk about future plans, kind of what's the future of this tool, what are we doing in Visual Studio Orcus to kind of productize this BLinq prototype, and talk a little bit about some of the design considerations we're going through in terms of like how we're some of the things we're considering for the Visual Studio integration, and maybe get your thoughts and feedback on some of those. So the BLinq prototype was sort of a pet project of a developer on the ASP.NET team, Polita Paulus, who would be here today speaking, but she's off on vacation, probably on some sunny island somewhere, so I'm filling her shoes. And she basically developed this tool as just kind of a demonstration of what would the canonical web form look like bound to DLinq Schema. And specifically, the tool's kind of targeted at this scenario where you're a developer, you just want to get a data-bound web form, a data-bound application up and running really quickly. And so how can you sort of point at a database and have a tool sort of examine the schema and the relationships inside that database and kind of produce a default set of web forms that you can then use as a starting point to customize and build your own apps. Another good kind of case scenario for the BLinq tool is if you just kind of want to build a web-based database administration application, it kind of gives you like a starting point for doing that as well. So the ability to sort of add and remove items from the database, kind of update rows, traverse the relationships of your database using a web front end. We also kind of see this as kind of a learning tool where somebody who really wants to kind of understand how the ASP.NET object data binding works, or how DLinq query syntax works, they can sort of use BLinq as a starting point to kind of learn the framework and kind of understand what that canonical web app bound to DLinq looks like. So learning tool. It's also like a quick and easy way to get starting point for your own apps or database management front ends. So it's hugely popular. It's been out since June. There are almost 10,000 downloads to date. I think for the DLinq CTP, it's built on top of the May DLinq CTP, and that CTP has about 24,000 downloads. So we're somewhere on the order, a little bit over than a third, close to a half of the DLinq CTP downloads. So it's a hugely popular tool. And it's available today for you to start playing with. It basically takes a connection string to a database, will traverse the relationships in that database, and create DLinq objects from that, and then it'll sort of generate a set of DLinq queries against those objects, and then a set of forms that are bound to those queries. And it kind of traverses all the relationships in the database for kind of wiring up navigation between the forms that it generates. It supports sorting, paging, update, insert, and delete operations on each result set by default. And then it has a variety of options, code generation options. So you can kind of choose if you want it to use if you want it to go ahead and format the output and kind of make it look pretty, or if you just want unformatted output because you're going to customize that later. You can sort of decide where you want the queries to be generated. Do you want them generated to each page? Do you want them generated on middle tier objects instead? So it provides a few customization options. And then as we're looking at integrating this into Visual Studio, we're looking at what are the set of kind of options and bells and whistles we want to put on this in Visual Studio to kind of give you kind of finer grained control over the output. So let's just start by demoing BLinq, and then we'll come back and talk a little bit more about how it works. So it's a command line tool, and it's installed in the Microsoft ASP.NET BLinq directory. If I run BLinq without any arguments, it gives me the usage. And essentially it just wants a target path where it should actually put the output files, and then some database credential information, what server, what database, optionally user and password for connecting to the database. And then, like I said, there's a few options, whether or not you want it to generate queries to the page, whether or not you want styled output or no styled output, and so on. So let's go ahead and just run it against the Northwind database. So I'll specify the target directory under inetpub. We'll call this my BLinq demo. Oh, maybe I should turn my email off. So I'm running a local SQL Express instance, so I'll go against that and choose to go against the Northwind database. And it can also optionally create a virtual directory. So you can either open the website as a file system in Visual Studio, or you can have it create a virtual directory in IIS, and it'll just launch the browser directly against that. So I'll create a virtual directory called my BLinq demo. And that's basically it. Give it the database, the server, where I want the output, and what I want to call the virtual directory. So it's going to kind of churn along here. At this point, it's kind of enumerating the database schema, doing code gen. It takes on the order of 10 seconds, maybe 5 seconds for the Northwind database. And then it launches the browser against that virtual directory. So what it basically creates is creates sort of just a collected set of web forms and an index page that kind of shows you all the forms that it generated, and some navigation to kind of go to each of the forms. So for example, I can go look at customers, and it'll generate a customers grid that I can sort and page across my customer records. I can edit or delete customers. And it also kind of looks at the relationships between objects in the database and generates navigation between records to other forms. So specifically for each record, it'll generate a details link that will go to sort of a details view of that one record using the ASP.NET details view control. And then if there are a related set of objects, for example, customers related to orders by a foreign key relationship, it'll generate a link to view the orders for that customer. And so it'll basically pass along parameters along the query string to those forms, so that those forms are kind of parameterized only to show the orders for the given customer that I navigated from. Then of course, if I want to see all orders, I can just go to the orders page itself. The other thing it does, it generates a kind of a new customer form, so I can basically say new customer and type in the values to actually enter a new customer. So basically it generates those three forms. For any given object, it'll generate a list, it'll generate a details page, and then it'll generate an insert form as well, and then wire up the related forms by looking at foreign key relationships. Notice that from customers I can go to the orders, and from orders here I can go to order details, but I can also go back to an object that if the orders table has a foreign key relationship to the customers table, I can actually navigate directly to the customer record as well. So it kind of supports two-way navigation of relationships, can view the orders for a customer, and I can view the customer for a given order. One other thing to point out, if I say go to the orders page and click edit, it generates some schema-aware insert UI as well. So we'll basically look at the foreign key relationships and say, because this is a foreign key, we'll go ahead and create a drop-down list that shows the unique set of possible values for that foreign key. We'll even sort of look at schema information such as, does this field accept nulls in the database? And if so, we should generate UI that will allow persisting null to the database. So this dropdown includes a selection for null as well. So basically look at those schema hints to kind of decide how we should generate the forms. So before I drill into kind of the code gen, I kind of want to pop back up, go back to the slides and talk about kind of some basics around object data source, and then kind of what BLinq does under the covers, and then we'll kind of come back and look at the code gen for this specific app. So the way BLinq works, it kind of goes through 3 steps. First, there's a tool that's part of the DLinq CTP called SQL Metal that will essentially generate the set of classes that map back to tables in the database. And BLinq just runs SQL Metal under the covers to do that. So the first thing it does is run SQL Metal and generates a set of objects that correspond one-to-one to the tables in the Northwind database. The next thing it does is it compiles those classes into a temporary assembly that it can reflect against, so that it can basically traverse the relationships between those objects and kind of build up a graph. Yes, there's a question. Right now, this runs against SQL Server. We are looking at incorporating this functionality into Visual Studio in the Orcus timeframe, and when we do that, it should actually be able to work against any of the supported providers in Visual Studio. I'm sorry, I'm having trouble hearing you.
Can you edit the output, like the way it looks?
Yeah, absolutely. Those are things that we're certainly considering as part of the Visual Studio experience. But the question was, can you edit the output that it generates? Well, yes, you can edit the output that it generates. Once it generates the forms, you can kind of customize those as you see fit. However, we're looking at should we provide the ability to kind of maybe template what the form output looks like ahead of time, so that you can sort of define some declarative templates. I want the forms to be generated in this way, and then as you walk through the wizard, its default output would kind of be customized by you. So we are looking at that as a possible introduction to the VS Orcus feature set. But BLinq itself is one-way code gen. It basically generates a set of ASP.NET forms, and from that point you can customize them as you see fit. And I'll do a little bit of customization to kind of show you, mostly just to show you kind of what DLinq gives you in terms of like the web data binding experience, and how it's better than the story that we have in Wimpy today. Yeah.
What is the killer scenario? Is it a tool for me inspecting the database, or
My 2 options were what? Is it a tool for inspecting my database?
Yeah, is it a one-off tool for inspecting databases, or is it a starter kit?
So I kind of enumerated what I thought the 3 scenarios were kind of at the beginning of the talk. I think one is you want to write a data-bound web app, and you want to get kind of up and running quickly. And today it's fairly quick to build data-bound web forms in Visual Studio. We have drag-drop gestures. We have drag a grid from the toolbox and choose a data source for it. Walk through a simple wizard, and you can kind of bind bind controls to data relatively easily. But if you want to build up a bunch of related web forms and kind of provide navigation links between your forms, you kind of have to cook up those links between forms manually and kind of build each form separately. And so we sort of see BLinq as sort of a rapid way to kind of do a lot of the work that you'd be doing anyway. And then from there, using customization, using Visual Studio to customize that output, you could kind of build a real data-bound app. I'll show how I might customize one of these forms that have a completely different rendering than what BLinq gives me. But we kind of want BLinq to have enough options on it that you can kind of select the options that are relevant for getting the right starting point for building a real app. It also is a reasonable way just to get a quick and easy way to kind of get a web front end to your database so you can administer data, add and remove, delete data. So it is kind of that tool for inspecting your database as well. Yeah.
Are you going to address how this tool also fits in with the new information worker vision?
Am I going to address how it fits into the new information worker vision? I wish I knew. I wasn't planning on covering anything like that.
The Office 2007 with the info packs and forms now, and the SharePoint web parts now, and all this new infrastructure that we have to create web applications.
Got it. I don't know if there's a direct correlation between this tool and some of the initiatives we're doing in the Office space for the information worker. I know that just kind of at a high level, we are doing a lot of work to make sure that the Visual Studio experience for editing web forms and kind of the Office SharePoint experience and Expression set of products, that experience for designing web forms start to converge and become more and more alike, so that you'll see kind of parity across what you can do in VS and what you can do in the Expression line of products. So it's certainly reasonable to assume the innovations that we do here might carry over there. In particular, this is a little bit of a tangent, but in particular we're integrating a new designer into Visual Studio Orcus that's basically the same designer that the Expression line of products use, and we'll be going forward as a shared component that will, every innovation we do to the design surface will be picked up by the Expression line, and likewise when they do innovations we'll pick it up. So we are doing more to kind of work across organizations on the web development story. But this tool specifically, I don't know that we've thought through what is the future vis-a-vis Office. Okay, so BLinq basically automates SQL Metal to generate classes. It compiles those and reflects against them and kind of looks at the schema to build up sort of a graph of the relationships between these objects. And SQL Metal attributes the objects and the properties of those objects with metadata information that we can use to figure out, hey, does this field accept nulls in the database? Is it an auto-generated field? What would be an identity column in the database? And these give us enough hints to know, how should we generate insert forms? Should we include this field or not include the field? Should we allow for nullable? Those kinds of things. And then with that sort of data graph and schema information, BLinq will generate partial class definitions with DLinq queries, with methods that basically wrap DLinq queries for doing operations like select, sorting and paging, update, insert, and delete. And these methods kind of correspond to the patterns that the ASP.NET Object Data Source requires for binding in a web form. And then the last thing it does is generates the ASPX pages that are bound to those queries. Yeah.
So I'm curious, what was BLinq written in? Did you guys actually host the ASP.NET runtime in the console app, like back there, to do your templating?
BLinq is just managed code. What was BLinq written in? So BLinq is just managed code. It was written in C#.
But did you host ASP.NET, right? Because you're generating code, right?
So we did actually have to write. So we are hosting the control designers in BLinq for doing the code gen of the forms themselves. So there's kind of two things for the code generation of the queries, the DLinq queries. We're actually just right-lining. I mean, we're right-lining statements in C# or VB. It supports two languages, VB and C#, but it literally has kind of baked in all the knowledge of VB and all the knowledge of C#. And the reason for that is that I believe the code DOM support for DLinq isn't in place yet, to where we could use code DOM to kind of automatically generate these queries in any arbitrary language that supports CodeDOM. Were that in place, we would be doing that instead. And then for the forms generation, we're hosting the ASP.NET control designers. What we do is kind of create the control, package up properties on that control, just kind of set the properties as you would programmatically, and then we use the control to sort of persist itself. So the designer knows how to sort of persist the control. So that's one of the reasons why BLinq currently only supports the grid view and details view controls, is because we're using the control persisters, and it's easier for us to set strongly typed properties on things like bound field and hyperlink field and all these objects in the grid view object model and details view object model than it would be for us to, say, generate templated controls where the templates are just arbitrary HTML content, which we would have to sort of, again, bake in static strings. That said, I think in the Visual Studio timeframe, we will be looking at generating templated controls as an option as well. So. Okay, so I kind of want to walk through just some examples of the code gen. So what SQL Metal generates essentially looks like this. You get a data context with a set of tables on it that correspond to each of the tables in the database. And so from a data context, we can sort of enumerate, what are the related set of objects that we care about. Then on each one of those objects, you get sort of like a one-to-one correlation, between the objects in the tables and the properties and the fields on that table. So for example, we'd have an order object, has an order ID, which is the primary key, foreign key relationships like customer ID. Again, like, if there was a field that accepted null, SQL Metal does the right thing and generates, for a value type date time, it would generate a nullable date time, so you can actually persist null back to the database. And then for related objects, it actually generates strongly typed properties that correspond to those. So in this case, order details has a relationship to orders. So order details has an order ID column or order ID field. And so on the order object, you'll have an order details collection, which is of type entity set, so that from any order object, you can kind of navigate into the order details collection. Likewise, because order has a customer ID field, which is a foreign key relationship to the customers table, it will generate what we call an entity ref, which is a reference back to the strongly typed customer object for this order. So that kind of is sort of what the object graph looks like out of SQL Metal. I mentioned that there's a bunch of schema attributes that we use to get hints. This is kind of a busy slide. The only real thing I wanted you to take away from this is that there's a set of attributes decorated on those objects and on those properties that kind of give us a bunch of additional metadata that BLinq uses to figure out things like, does the field accept nulls? Here, this one is not null, or isn't an auto-generated column, so isn't it an identity in the database? And so we kind of use some of those hints to figure out the right way to generate the forms. Right now, you'll see that there's both column attribute, which is something the DLinq runtime uses, and also this data object field attribute, which has a lot of the same information on it. The reason why we use data object field attribute is that it had some strongly typed properties for things like nullability and identity, whereas in the column attribute, we would have had to parse this string. And so it was just a little bit easier for us to reflect against that. But I think going forward, we'll be kind of innovating on column attribute and making sure that we can sort of just generate code from that and not have to have duplicate set of attributes on the objects. Yeah? Yep. Yeah, so the question was, what if I decided I only want to use stored procedures for my CRUD? Does this support actually using stored procedures for that? So DLinq does support stored procedures, a way that you can sort of map stored procedures to various operations. And that's something that in the VS Orcus timeframe, there will be support for doing that. So I think I'm a little embarrassed to say that when I looked at the code gen, I saw this /sprox option and wasn't even aware that it was there. So it may be that the BLinq prototype itself supports this as well. This specifies that database stored procedures should be included in the generated data context class. We can try to run it and see what happens. So yeah, I'm actually not sure what what the support is in BLinq, but we'll find out shortly. But for the VS Orcus timeframe, we are making sure that we consider Sprox support. Something that the DLinq designer will support, being able to map your objects to Sprox, and the BLinq wizard experience in VS Orcus will be built on top of the DLinq designer, and so kind of we're making sure that that integrates pretty well. Okay, when we walk through the code gen, we'll go kind of see what that generated. So I'll leave it for the future. Okay, and so again, like for foreign key relationships, there's something called an association attribute, which tells us basically that this is a foreign key relationship, and it tells us what the key is on the related table, for us to build up that graph. So the next thing BLinq does is it generates a set of methods, and what it does is it actually generates those methods on the partial class for the object generated by SQL Metal, so that when you compile this object, it basically has both the properties and a set of methods on it that correspond to the operations that we need. So this is again a really busy slide, but the idea is that we'll generate a method that gets all orders and returns a strongly typed queryable of order. We'll generate a method that gives us the count of all orders, which we can use for paging. We'll generate a get order by order ID, so we can sort of generate details from getting a singular order. And then for any of the foreign key relationships, we'll actually create a get orders by some related object and then pass in the foreign key for those related objects. So in here, an order has customer ID, shipper ID, and employee ID as foreign key fields, and so we'll generate those three methods as well. These complex set of methods are basically when there's more than one foreign key relationship, we actually generate a method that will take kind of all of them as parameters, and then allow you to specify which of them that you want this method to filter by. So it's kind of like a substitute for calling any one of these, but a way that you can use a single method to do it. And kind of the reason we do that is it makes it easier to have a single form that renders orders that takes in various permutations of query string arguments for the various foreign key fields. And depending on what query string arguments you happen to pass, this method will return the correctly filtered result set of orders. The reason we did this is, originally the BLinq prototype generated a different page for every foreign key relationship. So you'd have like the get orders page, then you'd have the get orders by customer page, and the get order by supplier page. And the problem is, if you wanted to customize what an order looked like, you'd have to do it in 4 different places to kind of just customize the UI for orders in general. So we kind of switched the design to have a single page, orders.aspx, that renders orders and is able to kind of filter based on arguments that you pass into that page, and it's bound to this one single method. So that kind of gives you some insight as to why we have this pattern. It's mostly about the way that we'd had to kind of do the data binding on the ASP.NET page and what the query had to look like as a result. And then lastly, for every object it generates update, insert, and delete operations, and I'm going to drill in a little bit as to like what the code gen looks like for those. So, but first, I want to talk a little bit about object data source and how that works. So, our object data source control in ASP.NET essentially just takes a type and a method and methods to bind to the select, update, insert, and delete operations. And so in that previous code gen example, the type would be order, and the select method might be get orders, and the update method would be update. And it basically just does this mapping. And then object data source will, through reflection, instantiate the object and call the methods for each of those operations. For selection, it only requires that the select method return an IEnumerable result set, which for DLinq it returns an iQueryable, which we can enumerate over, so that works. So when you look at the code gen for the queries, for the selection queries, to get all orders, we essentially just new up the data context and return the orders table collection directly off of that. For getting a single order, we'll create a data context and return the subset of orders where the order ID equals the value that we're looking for. So for sorting and paging, if you notice, like kind of on that earlier slide with all the code gen, there's overloads of the selection that take sorting and paging parameters. Essentially, like for paging, we pass in, we expect a parameter that is the starting row index, and then a parameter that specifies the total number of rows that you want the method to return. And the way this works is that our object data source, you can sort of tell it which parameters on the method correspond to those paging parameters, and it will pass along information that it gets from our data-bound controls, like the grid. It'll pass those values down into the method, and then the method can kind of do with it whatever it will. And in our implementation, the DLinq queries kind of use the skip and take operators in DLinq to kind of skip n number of rows and only take n number of rows, so that when you kind of are doing paging, you're sure that the DLinq query is only returning as many rows as the grid's actually asking for to render. So there's kind of three modes that Object Data Source supports. It can kind of automatically sort and automatically page, or it can kind of do this custom sorting and paging. And it's the custom sorting and paging of Object Data Source that BLinq takes advantage of. If you look at what the method signatures look like on the get all orders, for example, we generate an overload that takes a sort expression, a starting row index, and a maximum number of rows. And then inside of that, we basically get all the orders and then sort and page over those. This sort and page method is actually an extension method. So I don't know, this is a language symposium. How many of you are familiar with the extension methods in like C# 3.0? Okay. So we actually create an extension method that does sorting and paging over any iQueryable, so that for any iQueryable result set from DLinq, we can sort of do the sorting and paging using the skip and take operators. And then the last thing we do is we generate a method called get orders count that returns the total number of orders. And Object Data Source can be associated to this method so that it knows how to return the total number of orders back to the grid, and the grid uses that for rendering its numeric paging UI. So the grid kind of needs to know how many total orders are there in order for it to render render the right number of numeric paging buttons, for example. So for updates, inserts, and deletes, a key point is that the Object Data Source in ASP.NET supports this sort of stateless pattern. Normally with DLinq, you would be able to sort of query some objects off the data context, make modifications to those objects in memory, and then call submit changes on the data context to kind of persist any of the changes to those objects back to the database. And in kind of a client application, that's exactly what you would do. You'd have the data context alive for the lifetime of the app, and you'd be sort of manipulating those objects in memory and just calling submit changes whenever you wanted to persist them. In a web app, however, the selection of data and the update of data happen in entirely different page requests. So what happens is you select data from the data context, you render it out as HTML, it goes back to the browser, and then the original objects that we selected from the database, they vanish. The page instance goes away, and they're no longer there. And then when you actually do an update, we'll basically pass back a dictionary full of parameters back to the data source, and the data source has to figure out how to push those back to the database. So the way that works is Object Data Source will sort of new up an order object and package it up full of old values, and then new up another order object and package it up with all the new values, and then kind of hand that off to an update method. And so that's the kind of pattern that Object Data Source requires. In this case, you can pass, for example, like for an update product, you can pass a product object, and if you wanted to actually support, passing in the original values, you can set up this conflict detection property on Object Data Source to tell it to pass in the original object as well. and it'll call a method with this kind of signature. And that's basically exactly what DLinq does. So for the delete, this is what the code gen looks like. It essentially expects to get in an order, and it'll call remove on that, on the orders collection of the data context. For insert, it will call add on the orders collection. But update is kind of the most interesting one because it kind of highlights this stateless, the statelessness of the web scenario and how it's different from a client app. So in this case, the object data source passes in an original object and a new object, and we'll create a data context. And the first thing we do is actually attach this original object. So this is a feature of DLinq that was basically written, to support the web scenario, where you don't actually have the object that you selected in the first place, but you want to sort of reestablish that object's connection to the database at some future point. And so what's happening is object data source just creates a standalone order object. It didn't get it from the data context at all. And then it calls attach on it, which sort of reestablishes the identity of the object back to the corresponding record in the database. And then at that point, it's sort of like, once I've done that, anything that I modify on that object is being tracked as sort of a change to that object. And then it's kind of, from this point forward, it's just like the client scenario. I modify the object in memory, and then I call submit changes to persist those changes back. So that's, I don't know if that's clear to people. Yes?
So after you call attach, is original X updated to represent what was in the database? Or is it just used to basically set up the primary key?
It's used basically just to set up the primary key. It doesn't actually rehydrate the object from the database or anything. And the reason for that is, we still wanted to be able to support, we want to be able to support optimistic concurrency. So we want to be able to support kind of selecting out an object, saving off the old values, and then sort of rehydrating the object with all those original old values we selected, and then start tracking changes against it from that point forward. So it's kind of mimics, as if we had the original object in memory the whole time. But in the meantime, we had to do kind of a round trip of those original values in the view state for the page, and then rehydrate it on the round trip for the update. And in fact, I have 3 more slides, and then we're just going to go back to the demo. I have sort of a walkthrough of exactly how that happens. So in this case, imagine I have an object data source bound to a grid, and the grid will actually round trip any values that are either read-only or that it doesn't render. If you want to round trip those values, you round trip them in view state by setting those fields on the data key names property of the grid view. So in this case, the primary key is being round tripped in view state because I've set data key names equal to the ID. And so when I select data, for example, it hydrates. The grid will actually render these fields and store off the original value of the primary key in view state. And then when I actually put that grid into edit mode, the primary key is read-only in this case, so it doesn't actually allow me to update it. But say I update Bradley to Brad, and then call update to basically submit that back. And remember, my update signature kind of looks like this. It wants an original object and a new object. So what actually happens is the grid sort of extracts all the values from either view state or from the inputs that the user typed in, and it creates a set of dictionaries that it hands off to the object data source. So it puts all the original key values that were in data key names in the keys dictionary. It extracts original values that were rendered into an old values dictionary, and it extracts new values from the input fields into a values dictionary. So it creates these 3 dictionaries, and it gives them to the object data source and says, go update. And what the object data source does with those is it creates those 2 objects. It'll essentially create the original object using the keys and old values, and it'll create the new object, basically cloning this object first and then changing it with the new values. So the ID is still sort of the original ID that came out of keys. And then it passes that to those methods. So that's effectively kind of how the whole round tripping in view state works. Okay, so that's a lot of sort of under the hood. But I thought it was a little bit easier to walk through in slides than to walk through all the code gen. But let me go ahead and open up that website that we generated. I think I called it My BLinq Demo. My BLinq Demo. Okay. And so what you can see here is it generated a bunch of forms, obviously, and actually generates a sitemap and a master page for each of those forms as well. And then in the app code directory, we can see kind of both the objects generated by SQL Metal and also the set of query methods that BLinq generates as partial classes on top of that. So if I open up the Northwind file, this is actually generated by SQL Metal. You have the Northwind data context. Again, it has a bunch of tables on it, one-to-one mapping to the tables in the database, and then some constructor overloads for passing in a connection. And then for each table in the database, it generates a partial class and properties that correspond to the fields of the database. And these are those attributes that I mentioned. And basically, you could, for this whole file, there's just one object for every table in the Northwind database. And again, for the relationships, it generates entity sets and entity refs with collections of those related objects. And if I go off to the static methods page, you can see what BLinq kind of augments those classes with. For one, on the data context, it creates just a create data context method it can use to instantiate the data context, and then it just kind of uses that in all of its methods. Excuse me. And then on the partial class for each object, it will generate each of those methods. Again, one that gets all the customers, one that gets the count of customers, one that gets a customer by primary key, the sorting and paging overload that passes in those additional parameters that object data source requires, and then update, insert, and delete. And you can see basically the same code that we just walked through. And if I go look at, for example, one of the forms that was generated, so by default it'll generate a master page and kind of default styling, but you can turn that off. But it generates a grid and an object data source that is bound to one of those methods. So it's an awful lot of properties on here, but in this case it's bound to the category type, and for each method it's bound to each one of those methods. Uses the data object type name property to specify what's the object type that it should try to create from those keys and values and old values dictionaries to pass down to the update, insert, and delete methods. So in this case, it tells it to just create a standalone category object. Tells it what parameters to actually map down into the sort and page parameters of that method. And it's mapped to the count method for getting the total number of categories for paging. That's basically it. And then this grid is bound to that data source declaratively here. And you can see that for each of the related objects, it'll generate a hyperlink that kind of goes off to the related form, passing those values on the query string. So somebody was actually asking, before I kind of jump to the stored proc output, which I know somebody asked about. Somebody also asked about, can I customize these forms? So let's actually take a look at that. So let me open up like products, for example.
One of the questions I had about that was, can I tell it to generate without the edit, without the delete?
Can you tell it to generate without the edit, without the delete? So BLinq by default just generates, with the update, insert, and delete, automatically turned on. Again, for the VS Orcus experience, we want to have kind of more bells and whistles. So, and I'll walk a little bit through what that experience would be. And we are actually going to allow you to select whether or not you want edit, insert, and delete enabled. Is it important to you that the default output for BLinq it doesn't have those enabled, or? Okay. So yeah, you can. Excuse me. Yeah. Yeah, the question is, basically, how do we handle optimistic concurrency? If I select some data, I make an update, and in the meantime, somebody else had made an update to the row, will it fail? The answer to that is yes. So DLinq kind of takes care of that, and I sort of walk through how it works. So the basically, like when we round trip the original values and we sort of package up all those original values, and then kind of set the new value, we sort of attach that original object and then set a bunch of new values on it. Then we call submit changes. If any of the original values of the object don't correspond to the original value to the values that are in the database, DLinq will throw an optimistic concurrency exception. And so if you look at the Northwind objects that I was looking at before. So if we go look at this Northwind file, you can see on like every property, there's a column attribute. And one of the fields of the column attribute, even though it's not explicit here, is something called update check, which also is not showing up in my IntelliSense. But there's kind of three modes for update check. There's always perform an update check on this field, never perform an update check on this field, or only perform an update check on this field if it's changed. And what this tells DLinq to do is whether or not to basically match the value of that field in the where clause for the generated SQL statement that it'll generate. Yeah. Another question. Yep.
Anyway, would you say that I'm not going to update it, I just want to browse it, look at it, so that if somebody else wants to update it, they could. So anyway, to provide a record copy.
Well, so I don't think when you select the record, the underlying record in the database isn't locked. So anyone can go update it even if you're selecting it. I don't think there's a way to actually specifically lock the row once you select. I may be wrong, but I don't think there's a way that you can, explicitly lock the underlying database row when you do a selection. Whether or not you intend to update or not is sort of irrelevant to that. I don't think there's a way for you to specify that, unless this gentleman's going to tell me otherwise. Okay.
Any will doubts methods for security and for logging? Just having web pages that project information in the database is good, but giving access to information in the database to people and not others. Because very important for most applications.
Is there any provision for logging? Is that or login? Oh, login security.
Like all the transversal services that we put into an application.
Yeah.
That kind of get intermixed with
Right.
different layers that we don't know.
Yeah. I mean, by default, we don't generate any sort of like login code. Typically, with a data-driven web app, there's kind of two ways to approach security for the database. One is like the end user of the maybe the web app is like Windows Auth, is using Windows authentication. It's over a LAN, and the end user of the web app, you kind of want them to authenticate as themselves for the database connections. That's you may want the underlying connection string to kind of do that.
But most people don't do that.
Most people don't do that. Most people use something like Forms Auth, where they'll say the app itself kind of polices who can have access to it, and then kind of turns on and off functionality based on roles or some other kind of the app-specific permissions. And for that, it's kind of app-specific logic. So we don't really generate anything like that by default. It is something you can add relatively easily using our login controls and the membership framework in ASP.NET. But it isn't something that we plan to actually incorporate into the BLinq code gen.
I just can't wait to see how much work am I going to save with this compared to how much work am I going to have to pump into modifying what's been generated to add hiding of certain columns because I'm this person and I giving access to this information.
Yeah.
Like not this customer, or talking about contacts.
Yeah.
IDs to one person or other. Because I have to go to intertwine all that.
Yeah, so the logic to kind of hide and show fields and based on who's logged in, that is still sort of like custom code that you would kind of go in and modify the existing code gen. Yeah.
Question. So did you make any measurements regarding, for example, what you showed us, the north wind kind of thing? It's obviously unusable. It shows some crap like IDs in drop downs and so on. So
Yeah.
it would require some work to turn it into something more realistic. So did you measure on some realistic database like in VentureWorks?
Yeah.
So how long will it take to turn the generated application into something that looks like real?
That's a good point. I mean, like that's an exercise we should definitely go through. Is we haven't sort of. The question was, have we actually taken a case scenario example of like running BLinq over a database, like a relatively real-world database like AdventureWorks, and taken the output from BLinq and gone and kind of done the additional customizations that would make it suitable for like a real-world data-driven app. And I definitely think that's an exercise we can go through. Yeah, let me kind of demonstrate just a couple of things, like what you can kind of do with the generated BLinq output. So like one thing that came up is like, hey, the drop-down list show the foreign key ID, and maybe that's not what I want to display. So if I go to like this products page, for example, you can see I've got like a drop-down list showing like suppliers and categories, but by default it's just bound to to show like the supplier ID, because that's kind of our best guess at what we should render inside the drop-down. But chances are you actually don't want to render that. So the first thing I can do is change supplier ID to something like, let's say, company name on the object, and then maybe category ID, I'll change that to category name. And something failed, but let's see what.
I think about what was really important is for an enterprise,
Oh.
how much time am I really going to save? Because at the moment I can buy, let's say, code speech with .NET generate all the backend. If I'm going to start moving around, adding custom security logic and stuff like that, I might as well. I can use Aslan at the moment to live, have my login stuff like that.
Yep.
How much time am I really going to save? And when you start adding stuff to the code that's been already generated,
Right.
I mean, from a maintaining point of view, it's not necessarily a good thing.
Yeah. So I think the question was, how much time am I really going to save? I think the method generation, the query methods that we're generating. That kind of directly correspond to things that you can bind immediately to object data source is, to me, a huge time savings in and of itself. Now, whether or not the generated forms and the navigation links between the forms are a huge time saving, I think it kind of depends what kind of app you're trying to build. I agree that for some kinds of apps, it may be that like the query method code gen is more is kind of more helpful than the form generation itself. But yeah, I think it goes back to that gentleman's question. We really should kind of go through some case scenario examples of what it would take to kind of turn these into real applications. Right. So I did kind of want to just quickly show that I can change something like the what the drop-down lists are rendering by default. So, for example, now I can sort of like basically change the data text field for the drop-down list. Similarly, like because the product object has a reference back to a category, I can even kind of go to the labels that are being rendered for the. Let's see if I can find it. So here where it's sort of rendering supplier ID, I can instead kind of go against the supplier object and do supplier.company name. So I can actually traverse the relationships of the object just using like this dot syntax inside of the an eval statement. So kind of makes it really, really easy to kind of say, supplier.company name or category name, and go ahead and rerun that.
What was that update check you deleted earlier?
Oh, that was something that I was actually just demonstrating that there was an attribute update check that controls whether or not a field participates in optimistic concurrency. And so I just sort of mistyped it. I was answering some other gentleman's question, and I typed that, and so I just undid it so it would compile again. And now you can see, basically I've got kind of a customized rendering here. Well, let's say I don't want a grid at all. I want something like a data list or templated rendering or something. So for example, here I've got categories. It's just going to render a list of categories. Kind of show you some of the cool things you can do with DLinq. So I'm going to go ahead and just delete that that grid, leave kind of everything else the way it was, and go drag a data list control out here, and just go ahead and bind that to the data source, and have it automatically create a template that I can go customize. And then I can maybe go in and customize this rendering a little bit. Use the category, or maybe I'll show the category name and category description. And so I kind of want to show like a cool scenario where I can actually like nest data-bound controls and go ahead and traverse the relationships on the DLinq objects. So in this case, I'll drag a nested data list in here, and on this data list, go ahead and set the data source to. So remember, this outer data list is traversing categories, and so categories have. For example, a products collection. So I can bind directly to, an evaluation against that products collection, bind that kind of an inner data list against that, and then say in the item template for this data list, go in and evaluate now properties against this the product. So maybe product name. If we go ahead and run that. So now, instead of a grid-based rendering, I've got, each category, and for each category, I've got a list of products underneath that category. Relatively simply, just kind of like following the relationships in those DLinq objects returned by the query methods. So this just kind of shows that you can go in and sort of customize what you want that output to look like relatively easily using the designer. So I am a minute over, and I see people hovering, but I do actually just want to give you like a quick preview, and I'll kind of hang around if people want to talk a little bit more. A quick preview of kind of where we're going with this in Visual Studio. So obviously we're going to slap a UI on top of it. Some of the things that we want to be able to support are BLinq right now lets you point at a database and just generate the DLinq objects from that. But Visual Studio will also have a separate experience for generating a DLinq object layer kind of separate from the BLinq scenario, where you can use the DLinq designer to kind of easily through drag drop gestures build up an object layer. And so we want the BLinq wizard to be able to point at perhaps an existing DLinq object layer that you might have created separately or in a class library project, for example, and go ahead and kind of start from that point. So that's kind of one major change. Also, we want to give you a little bit more granularity over kind of which tables you want to include in your object layer, which fields you want to include, which fields you want to be visible in the generated forms. So we'll give you some UI for doing that. And then we also want to give you a little bit more granularity over which forms get generated. So for each object, do you want a list? Do you want details? Do you want edit on? Do you want insert on? Kind of give you those kind of options to customize what the generated output looks like. And then a variety of rendering options. One of the biggest ones being, do you want to generate templated controls, or do you want to generate tabular controls like grids and details view? You just saw me bind a data list to the DLinq output. One thing we're looking at for VS Orcus is a new control called list view, which is kind of a first-class data-bound control like grid view and details view and form view that can automatically update, insert, and delete data. So we should be able to generate fully templated output using list view and form view that supports all the same scenarios that grid view and details view do for updates, inserts, and deletes. So that's kind of just a high-level overview of the VS experience. We're also kind of considering smart tasks to be able to kind of add filtering and details to existing forms, kind of by again, looking at the object schema to do that. Since I'm out of time, I'm not going to really kind of belabor that point. And the last thing I want to point out are some of the things that we're considering for the VS Orcus experience. One is to kind of incorporate Atlas more into the generated output, whether that's wrapping the controls in an update panel or doing more. Kind of remains to be seen, but at least the update panel scenario is one that we would want to do. I already mentioned the list view and form view templated controls. Customizing the form code gen using templates. That's something a gentleman brought up in the back of the room that we are considering whether or not we should have a declarative kind of template format where you can go in and kind of tweak exactly what you want the generated form output to look like. Refactoring query methods to the page is something the BLinq preview supports that relies on a custom data source control, page data source. We're considering what it would take to actually support refactoring methods into the page in Visual Studio as well. And lastly, we're looking at putting extensibility hooks onto the BLinq wizard for potentially future updates, things that might happen post the VS Orcus release, whether that's supporting client application output in addition to web application output, or whether that's support for something other than the DLinq object layer, if that's ADO.NET entities, for example. So those are some of the things that we're considering in the future. So at this point, I'm going to turn it over to another presenter, and I thank you for having me.